Okay, here given that a 10 kg solid sphere of radius r is equal to 0.8 meter is rolling without slipping on a horizontal surface with a speed of v is equal to 8 meter per second. Now the force applied by right half on the left half is 30x Newton. Find x. That means the force between the right half and the left half. So the right half, so the left half is the right half, like this, and it is pure rolling. So that speed is given to be v, right? V is equal to 8 meter per second. So if I construct the free body diagram of one half, let me see. Constructing the free body diagram of, suppose we construct free body diagram of only the right part of this sphere. So the I mean the right hemisphere, that green one, right hemisphere. Now what are the forces on this? So there is a normal reaction, right, like this, and there is no friction. We all know that friction force is 0. So there is a normal reaction, pure rolling, friction force is 0. Okay, so let us look at the center of mass. This is the center of mass of the right part. So what is the distance of the center of mass? It happens to be this distance happens to be how much? 3r by 8, right? So this distance happens to be 3r by 8. Okay, so okay, so what we can do is that, so to find the acceleration of the center of mass, so from or velocity of the, okay, let's consider the point P here. This is a point P and this center of mass is named at C. So what is acceleration of C? Acceleration of C is acceleration of C as seen from P plus acceleration of P. Okay, now see, this is the x-axis, so I cap and j cap. So what is the acceleration of say this acceleration of P? Acceleration of P is r to omega squared times j cap, that we all know, and the acceleration of c with respect to p, so that means we have to draw this. So this is L, so acceleration of c with respect to p, magnitude is L omega square, that is this way, right, towards p, L omega square, and say this is angle, so this angle is theta, so L omega square, So acceleration of c is this L omega square. So this is L omega square cos theta, and this downward component is L omega square sin theta. Okay, এটা হচ্ছে acceleration of c with respect to p. C with respect to p, see any two points on a rigid body is in circular motion. Relative motion is circular motion. So acceleration of c with respect to p is towards p, L omega square. Now alpha is 0, constant speed of 8 meter per second. So alpha is 0. So therefore we get these two components. এটা আছে L omega square. One component is this L omega square sin theta. Other component is this L omega square cos theta. Right. Now leave apart the I mean, say if you have to at all write this, so acceleration of c is equal to how much? So so that is minus L omega square cos theta times I cap. Uh, then what? Uh, then minus L omega square sin theta j cap, and again you have to add that plus r omega square j cap. Okay, by the way, we'll concentrate ourselves with this, with the this one component, I mean the x component, L omega square cos theta. So this is the x, that's the component along the negative direction of x axis. Okay, so acceleration of c, its x component is minus L omega square cos theta. Now this L cos theta, if you look at the triangle, right angle triangle, L cos theta happens to be 3r by 8. Okay, L cos theta happens to be so minus 3r by 8 times omega square. So therefore this is the norm, I mean the force. Say let F be the force between the right and the left half. So force between right and left halves is equal to F is equal to, so mass, total mass by 2 multiplied by 3r by 8 times omega square. So let us put the values. You'll see this equal to m 10 by 2 times 3 by 8 times r 0.8 times, so omega square. What is omega? So 8 by 0.8, so 10 square. Okay, so what do you have here? If 5 into uh, 3 by 10 into 100, so 30x, right? 30 multiplied by 5. So this x, this was x is equal to 5.